how does one get started in this when they don't have a whole lot of data to work with?
Yeah, that's a really good question, and I think actually the clue is in the question. The problem is not it's never a lack of data. It's the most common problem is not seeing that there's a problem in the first place. It's defining the problem that you're trying to improve or trying to solve. It's one of the hardest things to do, because like unless you can just see a replica example, a copy paste equivalent, it's actually incredibly difficult to spot where you can apply these techniques and apply these methodologies. And in fact, it's not something that's taught that much, to be honest. I feel like when I sort of teach like so I have this idea in this chat that this talk that I give, where I say that software, ML and RL are kind of are automating different parts of the business. So at the bottom level, you've got software engineering, which is automating sort of basic business processes. So it's things like how to connect to your printer, send an email to this person when they purchase something, things like that. That's automating a process. Machine learning is automating the decisions. It's these one-shot decisions which occur in businesses, like should we accept this price, yes or no? Things like that. And then at the top level, you've got like strategic level business practices, which are defining things that happen over time. And it could be something as like innocuous as like C-level strategy, where you're defining where your business is trying to what your business is trying to do. And you could use something like reinforcement learning to kind of optimize your strategy and your direction for your business. So I think like thinking of it in that kind of triangle, that sort of pyramid stack. So even at the software engineering level at the bottom, like there's many things, many processes that you do every day that you maybe could consider you could consider automating. You could consider bringing in software engineering in order to automate those processes. And I think that because you can kind of visualize and enact those processes quite simply, it's relatively straightforward to be able to define how software can help you. Yeah. Take it up a level. And again, if you're thinking about the decisions that you're making on a daily basis, then it becomes a little bit more tricky, because decisions are often not written down. They kind of happen as a part of your job without you even thinking about it. Like you've like before we started this call today, you decided to set up the recording on this screen and that screen just because your past experience told you that things fail. Like we could probably automate that decision. The risk of Zoom not working or something. We could build a model to predict that, but actually actively thinking and deciding to do that is actually quite a difficult thing to do, because it takes some level of like stepping out of your you kind of like need to view what you're doing from an outside perspective. And then there's RL, which is the same thing again, but it's like not just single decisions, actually over a long period of time. So what are you doing on a daily basis that is trying to get you from where you are now to somewhere in the future? And trying to spot those problems is incredibly difficult. So I think, sorry, that was quite a long-winded way of describing that. Actually spotting strategies and choosing which strategies are the best to improve and optimize is a very difficult thing. And it's at the problem level. That's where most of the problem lies. It's not the data, it's not the tooling, it's not the technology, it's the problem.
Yeah. Yeah, it's funny in a way. Again, it is complex, but in a way, it sort of comes back to being simple again. As I think about like, and recently I talked with a friend who came to me for career advice. Whether or not to take a certain job or whatever. And it's, like you say, it's something I've just kind of done and only in hindsight sort of thought through. I always think anytime I'm considering a job, a project, or anything, I always think to myself, after I leave this job, project, or whatever it is, am I going to be closer or farther from my retirement goal? And whatever that may be, I may even be wrong, but, and in a way, I guess that's kind of, it all comes back down to this, you give this agent, I guess, a goal, And every step of the way, it's like, well, I don't know if I'm getting there or not, but I think I'm a step closer, or I think I'm a step further. Is that more or less a good way to generalize it?
Yeah, that's a good way to generalize it. And you're also introducing a really key concept there as well. And this is the idea of yeah, it's the temporal nature of reinforcement learning. Like machine learning is still pretty it's still tricky to use, but it's a lot more straightforward in that you're using a snapshot of data in time. It's like a fixed snapshot. It cannot change. It's effectively immutable at that point in time when you're looking at it. But with reinforcement learning, the context and the data is constantly changing. It's constantly evolving, and you need to be very careful when you're choosing these problems. That, like you said, you need to actually experience. You need to make these decisions and experience the effects of these decisions before you can actually learn from them. And so when you're giving career advice, it's a really difficult thing to do, because it takes many, many, many years for the effects of your decision that happened years ago to actually come to fruition. And reinforcement learning absolutely requires that feedback in order to learn. So you need to try and focus on problems that provides as a rapid amount, the fastest amount of feedback possible, so that the algorithm learns quicker. Because it's all great. Like, we could build an RL algorithm to optimize future earnings or something, but it's over such a long period of time that's kind of an intractable problem almost.